In modern database management, high availability is an issue that every enterprise must consider, and PostgreSQL physical streaming replication, as a powerful high availability solution, can help us achieve master-slave data synchronization and disaster recovery. Today, we will introduce the usage scenarios, implementation principles, and monitoring metrics of physical streaming replication in detail. PostgreSQL physical streaming replication synchronizes the master and slave by replicating the master's physical data files. Whenever data changes occur in the master, these changes are transmitted to the slave via WAL, write-ahead log, in real time to ensure data consistency between the slave and the master. Physical streaming replication not only improves the high availability of data, but also effectively supports disaster recovery. Physical stream replication is widely used in a variety of scenarios, mainly including high availability. In the event of a master library failure, it can be immediately switched to the slave library to ensure that the business is not affected. Disaster recovery. By backing up data from the slave repository, data can be quickly recovered after a disaster. Load balancing. The slave library can be used to share some of the query load and improve system performance. The implementation of physical streaming replication is based on PostgreSQL's WAL logs. When the master repository makes data changes, it first generates WAL logs and then streams them to the slave repositories via WAL sender. The slaves receive the logs and apply them to synchronize their data, ensuring consistency between the master and the slaves. In the master's PostgreSQL.conf configuration file, WAL_level is set to replica to enable replication. Max_WAL_senders is used to control the number of WAL sending processes, and WAL_keep_size is used to set the retention size of WAL logs. On the slave, we first need to get the data backup from the master via PG_base backup. After the recovery is complete, we need to create a recovery.conf file that specifies the master connection information. Primary_caninfo configures the connection information of the specified primary library. Standby_mode is set to on to indicate that the slave library is in standby mode. Trigger_file is used to trigger a failover. To ensure that physical stream replication is functioning properly, we need to monitor a number of key metrics. The main ones include latency. Check the latency between the master and slave to avoid data desynchronization. Synchronization status. Query the replication status through pg_stat_replication to ensure data synchronization between the slave and master. With the pg_stat_replication query, we can view the current status of the replication process, including latency time, synchronization status, and so on. If the latency is found to be too large, optimization measures can be taken. To summarize, PostgreSQL physical streaming replication is an effective tool for high availability, disaster recovery, and real-time data synchronization. It ensures data consistency between master and slave repositories through WAL log streaming replication and supports fast failure recovery and load balancing. If you have more questions about PostgreSQL physical streaming replication or want to know more in-depth content, welcome to leave a message in the comment section. And don't forget to subscribe to our channel for more database technology dry goods.